Hi everyone, welcome to the session Technical AI Safety Research and Overview. I believe we are all very excited to learn more about that. In this talk, Magdalena will give us an overview or explain the different research directions in technical AI safety currently. This talk is very beneficial for those of you who are already transitioning or working in AI safety or thinking that it's important or wanting to do that. Magdalena is currently doing independent research on the long-term future fund. And previously, she organized, for instance, the AI safety retreat, Europe retreat. Maybe some of you have been there this April. She also was part of the Winter Fellowship under John Venthorth at Serimatz. And there she concentrated mainly on interpretability, so a lot of knowledge there. Next to all of these, she also funded the EA Darmstadt in 2018 and has been the main organizer ever since. And we are not ending. There's one more interesting thing. So for many of us, path to AI safety might not be the most direct ones. We might be coming from different areas, and Magdalena has exactly done that. So she actually finished her bachelor studies in electrical engineering and transitioned to machine learning for masters because she saw the importance of AI safety and wanted to help with that. And yeah, she's redoing that, so that's very inspirational, amazing. And well, lastly but not least, Magdalena is also an amazing juggler, which many of you might have seen at summer camp or other events, but today she will be presenting us something, not juggling, but still it's amazing. So welcome Magdalena, and thank you all. Just a reminder, there is going to be Q&A at the end of the session. If you have questions, please post them via Swapcard. There is this live discussion button where you go, post your question, and the most upvoted ones will be used. And I think that's all from me. So enjoy the session. Thanks, Magdalena.
Thank you for this warm welcome. And yeah, I'd like to welcome you to my talk about the technical AI safety research landscape. And I'm very glad that you're here. This one works as well, right? Cool. So what I'm planning to talk about is, at first I want to do 10 minutes of a very broad overview of different approaches in AI safety and different actors. And then the bulk of the talk will be very concrete research that exists. And in the end, I'll do a summary and say a few sentences about how to get started. And then, as Alena already said, we'll have a Q&A. So yeah, you can find that on Swapcard. And at first, I'd like to get to know you. So just maybe a show of hands. Which of you think that AI safety is one of the world's most important problems? Oh, wow, OK. Which of you don't think that AI safety is one of the most important? OK, we have some controversials here. Nice. Which of you are working on AI safety research? Also a few. Which of you are planning to work on AI safety research? Nice. I think this talk will be particularly helpful for you. And which of you are considering to work on AI safety research but not sure? OK, cool. All right, a few things before about this talk. My goal is that after you come away from this, you have a rough idea of what kind of research exists. And I want to give you some kind of structure to think about things that you hear in technical AI safety research. And with technical, I mean it's a bit vague what I mean by this, but I mean something like it has to do with computer science or math or similar things. And I won't be covering non-technical research here. And a bunch of disclaimers. This is how I think about it, not necessarily how other people think about it. And it's a very emergent field, so I will probably be thinking about things very differently one year from now. And it's not the canonical view of this is how people think about AI safety, because there is no canonical view, because everyone thinks about it differently. And it's very simplified, and also I've left out lots of things, like it's very incomplete. But that said, if you hear about specific research here where you go like, this is super nice, I want to talk to someone who has more knowledge about this than me, you can fill in this form. You can scan this QR code. I'll also show it again in a bit. And yeah, I can probably, if you, like, it will ask you who you are and why you want to talk about a specific research direction, and I can probably introduce it to someone who knows more about it. And yeah, I think I want to really encourage you to fill this in if you're interested, because I think talking to people can just be very useful. And yeah, here are the links in big again. I wasn't sure if the small ones would be so scannable. And I also recommend you get the link to the slides, because I'll have a bunch of hyperlinks in here. So if you're like, oh, this sounds interesting, I want to read more about this, there will be, you can just like click on the link and read about topics. Okay, if you didn't catch them, I'll also show them in the end again. So now I'll get to an overview of research and actors. In general, for AI safety, what we want is we want to ensure that AI systems don't do really bad things. And there are various approaches to this, and one that is like a bit general, but like I would call alignment, which means make AI robustly do what we want. And then I will like split this up into different parts as well later. And I'm making clouds here because these distinctions are not very clear, and some things fit into multiple categories. Then there's meta-research about, like, one approach is automating alignment, which is about making AI do AI safety research, which is quite an interesting approach. Then there's a bunch of research that would fall under the category of deconfusion, which means we want to become less confused about the whole problem, because we actually are pretty confused still, and want to find better ways to think about it. Then a bit related to that is threat modeling, which is about telling a story about how AI might become dangerous and figuring out which ways of AI becoming dangerous are the most likely. Then there's evaluations, which is about showing current capabilities and potentially misalignment. Governance, which contains things like standards and regulations. And then there's interpretability, which is kind of the basis for other research directions. Like it's useful for a lot of alignment proposals, and also useful for things like threat modeling or deconfusion. And so alignment, it's like the big thing. What does this mean? Like, what do we align with what? So what we want is to align the thing that an AI does with the thing that we want. It's like make the AI do what we want and not some really bad thing. And that's why we call it alignment, because it's like aligning these two things. But we can split this up into intent alignment and capability robustness. And it's, so we say we maybe have two steps. We want the AI to want the same things that we want, and then we want it to be able to actually do the things that it wants robustly and not have any defects that might lead to some catastrophic failure. And then intent alignment can be split up again into so-called outer and inner alignment. And so the idea is that usually, at least if we do like deep learning, the AI is trained on something. And that's some mathematical function, like a loss function or a reward function. And but this function that we train it on is not the same thing as what the AI will end up pursuing as a goal, or at least not necessarily. And so, yeah, and one problem here is what we want is super vague, and also we don't really know who we is, because it might be some like idealized version of humanity probably, but yeah, it's not super clear. And then there's also the problem what the AI wants is not, there's no definition of what goals mean or what wanting means, and that's like an open problem. And yeah, these things, this is pretty simplified again, and I'm talking about one AI, but it seems likely that there will be like a multipolar scenario where we have multiple AIs, and this outer and inner alignment distinction is also not, like it's a bit disputed whether it makes sense to think about it with that distinction. I'll say a bit more about this later. Okay, and I'm now going to invite you to do a mini reflection, because I think it can always, like, often be a bit much. And if you feel confused about anything, or if you don't feel confused, if anything interests you, tell your neighbor about it. And yeah, if you don't have a neighbor, maybe come closer to someone and then you have a neighbor. I'll give you 1 minute. All right. I'll do a few more of these mini reflections throughout this talk. So yeah, you'll have the possibility to think about things and discuss. So now I'll say a little bit about actors in the space, like who is doing the research. And there's a bunch of organizations, most relevantly DeepMind and OpenAI, who are mostly focusing on capabilities, but they have also big safety teams working on AI safety research. Then there's academia, like universities, and independent researchers, like me. The most, yeah, these are the ones that came to mind, but also if I tried to search for who's an independent researcher, and all the people that I knew were like independent researchers before now aren't anymore, so it's often like a temporary state of affairs that you're independent. And then there's some loose communities like Eleuthera AI Discord, or yeah, Discords. But these often are like consist of the same people, which are like in the above groups here. Okay, so now I'll get to some concrete research that's happening in the different areas, and I'll start with outer alignment. So outer alignment means we want to find a function that captures what we want. So yeah, we can train an AI on this function. And the problem here is called specification gaming. And in this task, like this is a robot arm that is supposed to learn how to stack this red block on top of the blue block. And they specified it as being, yeah, like the bottom of the red thing is supposed to be on the top of, like at the same height as the top of the blue thing. And you see, it didn't work. It just like did an easier thing, which is like, it fulfills the specification, but it's not what we wanted. And the problem in general is we will miss something when we specify what we want, probably, because it's just hard to completely specify what we want. And one way to deal with this is called reinforcement learning from human feedback. And in this paper, backflip paper, it's called. Thanks. They try to make this leg thing do a backflip, but what do a backflip means is really hard to specify. Like, I mean, you can think about it, like how would you specify backflip? It's like kind of hard. But what ended up working is they let humans give feedback on what kind of thing looks like a backflip, and yeah, then it ended up learning how to do this thing. And reinforcement learning from human feedback is, or abbreviated RLHF, is used in language models like GPT, like ChatGPT. And the reason that ChatGPT is relatively nice is because they've used this reinforcement learning from human feedback thing. And a problem is that it potentially doesn't scale up to superhuman AI because giving feedback relies on us being to evaluate the output. And if we have like superhuman AI, that's not the case anymore. And even GPT still makes up facts. Like it's not, we haven't solved the problem of how to get it to always be honest. And yeah, potentially there are people who are always, who are actually worried that reinforcement learning from human feedback incentivizes dishonesty because it, yeah, it makes you, it wants to like tell you something that you want to hear instead of the truth. And now about inner alignment. So the difference in what the AI is trained on and what the AI actually ends up wanting. And the problem here is called goal misgeneralization. And this GIF here is about coin run. And coin run, it's a game where you want to get the coin. And what they did in this experiment is in the training environment, they put the coin to be always in the end of the maze, but then in deployment, they put the coin anywhere, like randomized position. And you see the capability is generalized from training to deployment, like it still manages to hop like over this obstacle thing and gets to the right place, like gets to the end, but it doesn't want to get to the coin anymore, like it doesn't act as if it wants to get the coin, even though it still gets negative reward, like it hasn't learned to optimize the reward, but it has learned to go to the right. And the problem is that the true reward is underspecified from the training, from the training time. So what we see here is even though our reward was correct, like we gave it the right reward whenever the coin, whenever it got the coin, it still ended up learning the wrong thing, and that could be quite a big problem. And then one solution might be to train in a more diverse environment. And in particular, we could do adversarial training, which means we search for examples of where it does the wrong things, like here with the coin, like going to the right instead of to the coin. And then we train on these examples. So for example, we would put a coin in a random position already during training. And there's a paper about this by Redwood Research where they tried it for language models. So they tried to use adversarial training to make language models never mention injury in their texts. But they didn't manage to fully do it. Like there were still quite interesting, like quite egregious examples of mentioning injury even after the adversarial training. So it's an open problem. And as I mentioned before, outer and inner alignment doesn't always make sense. And we often just want to do the thing directly without having some specified mathematical function of what we want in between. And one cluster of approaches that falls in this category is called scalable oversight. The idea is that we humans supervise AI that's gradually getting better over time. And one example is a paper of where they used AI to show that summaries in AI summaries that were written by AI had flaws in them, which is like giving humans tools to better supervise AI as it becomes better. And one approach here is called externalized reasoning oversight. And the idea is that we try to take a language model and make it think out loud, in the sense of reprompt it in such a way that it always like says what it's thinking. Then there's interpretability, because if we understand a system really well, then it's also easier to supervise it. And yeah, but how to scale it up to actually superhuman systems is still like an open question. Then there's shard theory. Shard theory is pointing out, which a thing that the reinforcement learning community partially knew but partially didn't know, that reinforcement learning agents are not actually optimizing the reward. And humans are also not optimizing reward in that sense, but instead we can think about it in terms of shards, like shards of value, and which are things we value in different contexts. And for example, if there's food in front of me, I value getting that food, and I will do actions that will lead to the food getting into my mouth. Or like if there's someone in front of me who needs help, I'll try to have like this goal, or I'll have this goal of helping them. But it's not some kind of big overall utility function where I don't know, care about, like, humans are not consistent in the sense of you could describe them as utility maximizers. And so the hypothesis is that this shard thing also happens in AIs, and understanding this process, how these shards form better in AIs, is the research agenda of shard theory. And the hope there is that it helps us make the AI what we want directly without having to specify this mathematical function. And shard theory would also inform us how much we have to worry about things like power-seeking behavior that come from utility maximization, for example. And the next part is about capability robustness. So even if we get an AI that wants what we want, maybe it's not able to like fully do that. And in particular, there's like deep learning, so neural network-based systems have like super weird failure modes. Maybe you've seen this image before. Some image classifiers think that this is not a stop sign, and yeah, it's not robust yet to recognize images. And how to make these systems robust is an open problem. Then, so all of these were the alignment cloud. Now get to an interpretability cloud, which is about understanding systems that we already have better. And one way to do this for image classifiers is to do feature visualization, which means we are visualizing which things neurons are activated by. So we'd probably get a building neuron here or an insect neuron here. And there's also a cool paper called Discovering Latent Knowledge, which found which was basically a lie detector, like not a perfect one, but a lie detector for language models, because it found a representation, like a thing in the weights of the neural networks that represented this is true or this is false. Interpretability is a relatively large subfield of AI safety, and I think the reason for this is that it's very hands-on and practical, and you get quick feedback on what you do, because you're always working with current models. And it's also needed for a lot of proposals, so it's very useful. But there's also a worry and a discussion ongoing about dual use potential, because if you understand current systems better, you're also, like, this contributes to capabilities, because you're also then able to make them more capable. And Callum McDougall is going to have a talk only about interpretability tomorrow. So if you're specifically interested in that, go there. All right, I'll have another mini reflection. I'll give you 1 minute to talk about what's on your mind. Okay. I'll go on to the topic of evaluations. Evaluations, or model evaluations, are about showing what current AI systems can do. And this is very useful for informing both what other research needs to be done, and also for making good arguments for example, slowing down capabilities and regulating AI. And for governance, there's a bunch of non-technical research here, but there's also some technical work in AI governance. And if we want to, for example, regulate compute to slow down development of capabilities, we somehow need to enforce those regulations, and that's a technical problem. And one example for work here is this paper called "What Does It Take to Catch a Chinchilla?" It's called like this because there's this language model called Chinchilla by Google, and what it does is it makes a proposal for regulating compute, which is about letting chips log snapshots during training, and then they devise a protocol to verify that only certain types of training happened. So you can use this to enforce regulations. Hopefully, it's not been used in practice yet. And I think this part is, like, this kind of research is particularly interesting if you're into crypto or IT security. Then the automating alignment cloud. This is the main plan of OpenAI. Like, OpenAI is a pretty big player, and that's what they want to do. They want to make AIs do alignment research. And the open question here is how we make sure that these artificial researchers themselves are aligned. And yeah, different people are differently optimistic about how well this can work. And one example would be automating interpretability. One paper they had is where they used GPT-4 to explain the neurons of GPT-2 And sometimes it worked, like often it was just wrong, but sometimes it worked in a way that was actually helpful. Like they found a neuron called Canada neuron that they wouldn't have found otherwise. And then deconfusion. Deconfusion kind of has the assumption that we need to get a way better foundational understanding before we can even do useful alignment proposals. And one example for deconfusion research is the natural abstractions research. And what is a natural abstraction? The natural abstraction is, for example, if we have this image here, we would think about it as here's a table and here's a water bottle. But we also might be like, okay, here's like the table's left half, and then here's the water bottle plus the table's right half, like just carve reality differently. But somehow we all think about it in this way and not this way. But is there some like fundamental difference between these two ways of thinking about it? And this is important because if we understand what abstraction means, like why we have the same abstraction of water bottle and table, this helps finding formalizations of things like optimization and goals. And also, people value things that are abstract. Like even if reality is made up of like quantum fields and stuff, I don't really care about quantum fields. I care about people and friends and stuff like that. Then threat modeling, figuring out how AI might become dangerous, is just, super useful for informing where to direct our next research efforts. And one example is this paper called What Multipolar Failure Looks Like. And this basically makes a point of everyone's talking about one AI being aligned with like people, but actually we will have potentially lots of AIs, and here are some ways to think about this. And I like this literature review of different threat models. Then I'll go into disagreements for a bit. Disagreements that I'm most aware of in this AI safety research community is, the first one is, how will the capabilities develop? And there's people who think it will take a long while, and some people who are like, it's going to happen really soon. And then some people are like, if it's happening, how quickly does it happen? Like, how many warning shots do we get before we have superhuman AI? And there's its own subfield predicting these, like, how will capabilities develop thing. Then another main disagreement is how difficult alignment is. And some people are like, maybe we'll actually get, like, maybe it's actually easy. And some are like, it's literally impossible. So it's a very broad, range of opinions here. And also there's like a broad range of opinions how feasible different approaches are. Like, for example, OpenAI is very optimistic about the automating alignment approach, and other people aren't. And then the last disagreement is that some people think safety research might advance capabilities. For example, what I mentioned with the interpretability, but also, for example, reinforcement learning from human feedback, because making ChatGPTs as useful as it is got lots of people interested in the field, and potentially, in the end, ended up just accelerating everything a lot. I already talked about interpretability, and then, the question is like how much to publish, versus because some things are just dual use, and we might just not publish them, but just send the research results to a smaller group of people who are working on safety research. Okay, another mini reflection. All right. We're nearing the end. As a summary and yeah, how to get started. A summary, we have various areas of research. One is something we could call alignment, which can be split into outer alignment and inner alignment and capability robustness, though the outer alignment, inner alignment distinction doesn't always make sense. There's meta-research, like automating alignment, deconfusion, like finding better ways to think about AI safety, threat modeling, evaluations, governance, and then there's interpretability, which is helpful for both alignment and deconfusion. And so what I've been doing can be like categorized into these in this framework. Something that I'm currently doing is there's this research agenda called Wache. It's an outer alignment proposal, and I'm currently evaluating whether I think that this proposal can work or not. And I'm doing this on my long-term future fund grant. And in interpretability, that's, as Alena already mentioned, I've worked on this in Cerimats, and I've mostly done this, I've done very theoretical work on this, like neural network theory, like taking a theoretical lens on what the heck's going on inside neural networks. And in the deconfusion cloud, there's this mathematical structure called finite factored sets, which is useful to talk about what it means for an AI to want something, like to be an agent, and also for abstractions. And I've written this article called Finite Factored Sets in Pictures, which has a lot of pictures explaining how finite factored sets work. And yeah, the AI Safety Europe retreat that Alena also already mentioned is something that isn't technical research, but it's very related because like it was a retreat where we got 70 people to come together, people who worked on AI safety, to learn things and network and just generally make progress on AI safety. And I think this kind of thing is just super important as well, because it's cool if you do research yourself, but if you support other people, do better research, that can be super impactful. Yeah, so if you're, after this intro, you're like, I want to work on AI safety, here are my favorite resources. I think I won't talk about all of these, but it's articles basically giving an overview for how to get started. All right, that's it. Here's the QR codes again. And also I want to plug, I'm looking for a job starting in December, where ideally I can do research or organize things, or both. So yeah, if you feel like working with me, tell me. Here's my email. Thanks.
Thank you, Magdalena, for this amazing presentation. I think we all learned a lot. So we have some questions in the chat. And reminder, if you still have some questions, you can also add them there. The first one goes, does specification gaming mean anything? Isn't this the AI learning precisely what the human put in the loss function?
Yes, exactly. And but it means anything in the sense of this is like if you say, yeah, it's doing what we asked it to do. This is correct. Like it's doing what we asked it to do, but and it's like a real problem that we don't know what to ask. So that's the problem.
So I hope that clarified it. Yeah, and another question we have here is, could you say a bit more about how we differentiate normal capability failures of misgeneralization from goal misgeneralization? Okay. You following? What difference do we mean between both cases in the reinforcement learning agent?
Mm-hmm. So, like the example I gave was the coin run thing is able to do like to navigate the environment well, but the goal was wrong, and I think like in this case it's somewhat clear just from looking at it, but there is no definition exactly. Like it's for some things, for example, for GPT jailbreaks, like where you just prompt it right and it will suddenly tell you how to build a bomb or something. That's a bit unclear if this is like a capability failure or an alignment failure, because we don't really know if GPT quote-unquote wants, or if that even means something for it to want something, if it wants to tell us how to build a bomb or not, or if it's just like tricked into it in some sense. So whoever asked the question, you're right that there's no super clear distinction here.
Another one, as you research interpretability, how far do you think we are with accurately explaining to regular humans why complex AI models make certain decisions? Or maybe not regular, like maybe to us, at least.
Not particularly far. Like there's the mechanistic interpretability cluster where you like look at the weights inside the neural networks, and that's like very, like, because you have billions of weights in there. So it's just not feasible yet to, like, you can have some information about some parts of it, but we are definitely not covering the whole thing. And then you have stuff like chain of thought, or the thing that I mentioned about like making models think out loud. So they go like, the first step in my reasoning is this, and then the next step is this. But this, if I recall correctly, has been also shown to not be faithful in the sense of it's not actually using the things that it says. It's like it's not actually reasoning the way that is displayed when you tell it to reason out loud, at least not always. Does this answer the question?
Yeah, I hope so.
Yeah.
Yeah, if you have follow-up questions, put it in the questions, right? There's quite a lot of questions coming up now, so there is one pretty specific. I like it to read. Does quasi look promising to you? Could you throw some like probabilities of success or like?
Oh, probabilities of success. This is hard, and it's going to be very low because there's like a baseline that is relatively low. But the reason I'm working on it is that I think it's relatively promising compared to other approaches. So. Yeah, sorry, I don't have numbers, but relatively promising overall. Given that there's so many approaches, it's like unlikely to be that this is the one out of all of the possible approaches.
Another quite specific question, I like that. How developed is the natural abstraction subfield? Can you answer that?
Mm-hmm. So natural abstractions is mostly done by one researcher called John Wentworth, and he's like the main person behind it. He has some other people working on it as well, but he's... So he has some starting points of, like, he has some theorems where he makes proposals of how we could formalize what we mean by abstractions. And in particular, he says this is about information that is preserved at a distance, which I think is an interesting way to look at it. Like, I can perceive of the information that Alena is there, and it's like still the case when I'm like going farther away, whereas I can't conceive of her quantum fields. But there's definitely been critiques of Jan Wentworth's work in the sense of it's not going very far yet. Yeah.
There is a follow-up question to this. Has there been interdisciplinary research done with cognitive scientists? Like, is there some, or is it just John?
So John, I think, is coming, like he started looking at things from a biology point of view. So he started out looking at this little, I think, worm thing, where he was like, is this worm an agent? Like, it's kind of optimizing for something. It's like swimming around, going towards the sugar. But like, it's still like super simple. And then, yeah, he came from that. I'm not sure if cognitive science is in particular something he's looked into. Yeah.
Interesting. Now there's going to be more general questions. So what areas of alignment research do you believe are most pressing and or promising?
This is really hard.
But everyone wants the answer for that, right?
Yeah, I was anticipating this question. I actually made a slide for this because I asked myself this question. I'm still not sure, but let's see.
Let's Google that.
Wait, this is a German. Oh no, I'm not able to use German keywords. I can do it. There we go. It was like, I did a bunch of slides that didn't end up in the presentation, and it's this one, yeah. So, yeah, I think that maybe we don't manage to solve it, but if we do, can I make this a slideshow? Nice, yes. But if we do, I think the reason is that it might just actually be relatively easy, and in particular that the automating alignment works with scalable oversight. Like we managed to successfully oversee artificial researchers that solve the problem for us. And then I also think it might be something like it's completely impossible. Like, in that case, the thing that we should do is something like regulate real hard, even though I'm pretty pessimistic about this. And then the most likely thing that I think is that it's pretty hard and automating doesn't work. And in that case, I think the main things, like the most pressing things, are interpretability and deconfusion. Yeah, just understand really well what's happening. Yeah, what agency optimization, abstraction mean, and then based on that, build a system that's robustly aligned. And yeah, or something like some clever other alignment scheme, which is, for example, Wache. Yeah, and I made this in like 5 minutes. Like, don't put too much weight on this.
Yeah, there is actually a follow-up question, like what's quasi approach?
Mm-hmm. Yeah, well...
Thank you for asking.
Here we go. So Wache is a research agenda by Temps and Leak, and it's an outer alignment proposal. Oh no, I see that everyone's now here in my slides, which I planned to not be the case. Well, Those are the slides that didn't make it in because I don't endorse them, right? Like most of them, some of them. So Wache is an outer alignment proposal. The goal is to define a function which robustly captures what we want. And by robustly, I mean it's that the result is still good, even if we optimize really hard for this function. So a function that is robust to specification gaming, basically. And the idea is that this function, we might, we can define it, but it does not necessarily have to be efficiently computable. And the more an AI is resolving its uncertainty about what the thing is, and it's called logical uncertainty because it's not actual uncertainty, it's like clearly defined, but it takes a while to actually compute it. So the more it resolves this uncertainty, the better it knows what we want. So we get some alignment in the limit of very extreme capabilities. And the way that it's defined is as some sort of counterfactual simulated long reflection. So a simulation of what function we would come up with if we had as much time to think about it as we wanted. And the core difficult part of this is how to define what simulation means and what counterfactual means. And there's a bunch of math around that. And yeah, I think it seems promising. And also I like that it's relatively concrete. And what I currently want to do is understand it well enough so that I can actually evaluate and have an opinion about whether this thing can work or not. Yeah, why it's called question-answer counterfactual interval, I think it's not ideally named, but the reason is because of the structure of how this counterfactual simulated long reflection is defined. I don't think it makes sense to go into the details here, but yeah.
Okay, I hope that clarified it. At least it did a bit to me. I guess...
I think we're out of time, right?
We are out of time, yes.
Like, otherwise people can't go to their one-on-ones.
Yeah. So thanks everyone for a great question. Thanks again, Magdalena, for an amazing presentation. And let me finish.
If you have more questions, you can come to my office hours. They are at 5:30 in the room Kepler. Have a good conference.